first thing that you want to get straight when dealing with logarithmic functions is being able to convert between exponential and logarithmic equations. You're going to use logarithms to solve for exponents. Now, ideally, you would use the principle of exponential equality, which would say that we can get, if we can get the bases the same, we would set the exponents equal to each other. But most numbers you can't break down into the same bases. So we're going to use this idea of the logarithm. Now this is a number raised to an exponent equaling x, okay, and this number would be our base. This is read y equals log base b of x. So again, we're going to use this idea to solve for exponents. So you notice that the exponent in this comes out front, because that's what we're solving for. Our base in this situation is our base of the log, and then our other number comes and joins the log base b. So let's run through a couple examples of just changing an exponential equation into a logarithmic equation. So we're going to take our exponent, okay, and that's kind of what logarithms are used for a lot, and that's what we're going to put out front. So x equals, now we have a base of 2, so we're going to say log base 2 of 8. Right, we're just moving it to a different form. So let's look at this next one. Okay, again, logarithms are used to solve for exponents, so we're going to say -1 equals log base y. Right, our base was y here, our base is y here, of 4. So again, we're going to say our exponent equals, we have a base of a, so log base a of c. Okay, so that's the whole idea. If you can do that, if you can get that memorized, dealing with exponential equations and logarithmic equations is pretty simple. So let's go in the other direction. We have 3 examples of logarithmic equations. Let's change them back into exponential equations. This is read y equals log base 3 of 5. Remember, a log is used to solve for exponents. So here's our exponent and here's our base. So we have 3 raised to the y power equals 5. So let's move on to the second example here. We have a base of a and an exponent of -2, and that equals 7. Right, again, the bases are the same. Logarithms, if you think of them as exponents, right, this equals an exponent, and then 7. So this final one, right, our logarithm equals an exponent. So we have a base of b, an exponent of a, equaling d. So this relationship between exponential equations and logarithmic equations can be very useful for solving certain types of logarithmic equations. And I'm going to show you a couple examples of when that would be. So we have this log base 2 of x equaling -3. So let's just change it into its exponential form and see what we get. Right? A logarithm equals an exponent. Okay, so our exponent here is going to be -3, and our base is still going to be 2. So we have 2 raised to the -3rd power equaling x. And so we can actually solve this equation for x by simply doing some exponent rules. X is the same as 1 over 2 cubed, which is 1 over 8. So let's take a look at another situation. Right, our log base x of 16 equals 2. A logarithm equals an exponent, and our base is the same. So in this case, the base is x, our exponent is 2, and that equals 16. So we'll take the square root of both sides, and x equals a positive and a negative 4. Just be very careful about what you're doing when you're switching these logarithms into exponential form. Remember, a logarithm equals an exponent. So this whole side is an exponent. Alright, and just make sure you understand that. And so when you switch this around, our base is 4, and all of this is the exponent that equals 64. Now we're going to use this whole idea of the principle of exponential equality. We're going to get our bases the same, and that means we're going to, you could go all the way to 2, but we can write 64 as 4 raised to the third power. And now we have like bases, so we can set our exponents equal to each other and solve. So we would have 3x equals negative 3 and x equals negative 1. So we'll use this idea of converting between the two types of equations for these two examples. Again, a logarithm equals an exponent. We have a base of 10, so when we translate this into the exponential equation form, we have 10 to the x power equals 1,000. Okay, now we're going to use the idea of the principle of exponential equality, and we're going to get the bases the same. Okay, and again, I always deal with the bigger base. And so we're going to rewrite this as 10 to the x equals 10 to the third. Since we have the same bases, we can set the exponents equal to each other. And so we know that x equals 3. And we're going to move on to this other equation, log base 4 of 1 equaling t. T is our exponent, 4 is our base. And we have to understand that the only way we can raise some base to an exponent and get 1 is if that exponent actually equals 0. So the previous example illustrates something about a log of any base of 1. Okay? A log of any base of 1 is always going to give us 0. Okay, and that's because the only way, if we switch this, so let's say we don't know what it is, and again, we'll call it t like we did in the previous one, and we switched it, a to the some power gives us 1, well, it has to be 0. So no matter what, log base of any log of any base is going to be 0. Another situation that is a good idea to understand is what happens when the base and the number are the same. So this is read log base a of a. Well, anytime these two numbers are the same, it will be 1. Okay, so again, let's take a look at why that is. So let's say we don't know what it is. We'll say, well, maybe it's x. And then we switch it to its exponential form. And, we're going to use the idea of the principle of exponential equality. If we have the same bases, we can set the exponents equal to each other. Well, the exponent here is 1. If you don't see 1 there, it means it's 1. So x is 1. So, no matter what, log base whatever, if that's the same number, log base a of a is always going to be 1. So here's a couple other things you want to keep in mind. There's something called a common logarithm, and all a common logarithm is referring to is a logarithm of base 10, and that's just written as log. And this is called common because this is the one that's used very, very frequently. There is another logarithm called natural logs, which is log base e, and we'll talk about that in a different video. But if you're looking at your calculator, you can find just a log button, okay? And that button is log base 10. And this is an equivalent statement here. Log of 54, if you just say that, if you don't mention any base, you're really saying log base 10 of 54. The number x is called the anti-logarithm of log of x. So 54 is the anti-logarithm of log of 54. So this whole idea of solving exponential equations and logarithmic equations by converting back and forth in between them is very useful, but the idea of the principle of exponential equality is very limited. The only way that works is if we can get the bases the same, and most numbers just can't do that. And we still want to be able to get an answer on these. So there is something called the change of base formula, and this is what it looks like. Okay, so remember that we're talking about variables here. So log base b of x. Okay, and if you try to solve an equation that was set up this way and the bases didn't line up, you'd kind of be stuck. Now you have these calculators now that can do log and natural log. So you're allowed to use this idea of changing the base. Okay, so if you just had log base 10 of x, log base 10 of 5, you could just punch that into your calculator and find the answer. But if there's a log base of a different number, your calculator can't handle something like that. So what you can do is say, I'm going to choose any base that I want. Now the hint is choose base 10. Okay, you could choose e also, but you got to choose something that your calculator can handle. So you're going to say, well, log base b of x, I'm going to rewrite that as log base whatever I want of x, and you see that I kind of remember this by saying, well, this number is above this above this number, and so it goes up here, divided by the log base of the same one that you chose of b. Okay, and you do that and it will give you the equivalent expression. Now some of these newer calculators allow you to actually change the base of a logarithm. And so some of the newer TI-83s, you can choose a log and it'll give you an option on what you want your base. And so you wouldn't need this if you have that kind of calculator. But a lot of people don't have those calculators, and if you just have a scientific calculator, that'll work just fine because of this formula. So you might need to get this memorized if you need to solve logarithms or exponential equations. So here's an example of what I was talking about on the previous slide. You get this equation, you want to solve for x, so you say, well, okay, I'm going to just switch it into the exponential form. So 3 to the x power equals 17. And you try to get the bases the same, and you can't. Okay, so you say, well, maybe I can just type this into my calculator and find out the answer. But the problem is your calculator can't handle base 3. So you're going to use the change of base formula. And you're going to pick what base that you want. Now, most calculators can only do log base 10 or the natural log. And so let's just use log base 10 right now. We can say that log base 3 of 17 is the same as log base 10 of 17 divided by log base 10 of 3. Now we are setting it up for what a calculator can handle. So you can just punch in your calculator. So log base 10 of 17 is approximately 1.23, and I just got that from the calculator. And log base 10 of 3 is approximately equivalent to 4.477. Okay, and if we divide those out, we will see that log base 3 of 17 equals approximately 2.579.